Class, I'd like to talk a little bit about the measures of central tendency, Chapter 3, the mean, the median, and the mode. And let's get right into it. Your author says that the mode is any distribution of scores. In any distribution of scores, it's the value that occurs most frequently, right? He gives you a little example, 58, 82, 90, 98, etc. What number appears the most frequently? 82, right? That's the mode. By the way, if these were exam scores, 58, 82, 82, 90, and 98, I could also calculate the mean average, couldn't I? So if I treated them as exam scores, that would be interval ratio level. If I didn't treat them as exam scores, just as, you know, representations of a number but not actual numbers, 58, 82, 82, 90, and 98, I would be looking at the mode. Another way of looking at that, if I had 20 zip codes and I wanted to know, you know, which zip code had the most people in it, or I'd look at the zip code and I'd look at the number of people and I'd say that zip code has the most people. Even though the zip codes are numbers, we don't treat them as numbers. We just treat them as labels, categories, names, nominal, right? Low level of measurement. So if you look at the table below, table 3.1, you'll see that you have the variable city, and the attributes of that variable are each city. You want to know which city was visited the most. You're dealing with the mode, right? You look at the cities and you see which city had the most visitors. It's New York City, and you go on from there. Okay. Please, again, don't skip any of the boxes. The median. Well, the median is best when we're rank ordering data, right? The median is also useful when we have a list of numbers with maybe one really high score or one really low score. Let me talk about the second piece first. If we had a list of exam scores, and most of the students got between 70 and 80, and well, let's say 2 students got zeros. If I added all those numbers up, including the zeros, the average for the class would be pulled way down because of those 2 outlying zeros. They're outlying scores. They're very low. They're not typical of the list of numbers. So in that case, we might want to use the median. We might want to rank order the exam scores, including the zeros, and then count up from the bottom to the middle of that list, and that middle score would be the median, right? Half the scores would be above the median, half the scores would be below the median. And then the zeros wouldn't be messing us up by pulling or skewing the list of exam scores. So when you have extreme scores, sometimes it makes sense to use the median, right? It also makes sense to use the median when we have ordinal level of measurement and we're rank ordering the data, and we can't really figure out any mathematical computations because it doesn't make sense to do so. Now, there's a really neat little table, table 3.3, that explains to you how you find the median if the number of cases on the list is an odd number, and 3.5 tells you how to find the median if the number of cases on the list is an even number. That's really important, by the way. Don't get confused by it. Remember, what we're doing when we do the median is we rank order the scores, the lowest number to the highest number. We want to find the middle score, so we want to divide by 2. But when it's an even number of scores on the list, dividing by 2 doesn't give us the exact number that we're looking for. So we take the 2 middle scores. That's explained to you, by the way, in table 3.5 very nicely. Pay attention to that. That's a crucial point, and a lot of students usually overlook that. Again, the one step at a time boxes are outstanding in this chapter, right? So some more descriptive statistics to pay attention to in this chapter are percentiles, deciles, quartiles, etc. And your author explains very nicely how you calculate those, and I want you to make sure you take a look at those. And remember, a quartile, for example, means that you take a list of numbers, rank them low to high, and you break them up into quartiles, right? What is the range of numbers that falls in the first quarter, the second quarter, the third quarter, and the fourth quarter? The first quarter is called Q1, which is a quartile, and Q2 is the second quarter, that's a quartile. Q3 is the third quarter, that's a quartile. Q4 is the fourth quartile, right? If a score falls at the 25th quartile, it falls at that place where 25% of the scores on that list fall below it, and 75% fall above it, right? In percentiles, and you probably have heard these things when you took your ACTs, SATs, or achievement tests in school, you got a percentile rank, right, which compared you to everybody else who took the test. And so if your percentile rank was 60, it's the 60th percentile, it means you did better than 60% of the students who took that exam, and you did worse than 40%, right? That's how that works. Deciles breaks a list of numbers into 10%, tenths, right? Quartiles, quarters, deciles, tenths, percentages breaks it up, of course, according to the percentage number. This is an important discussion, but not a hard discussion. So please make sure that you understand how to calculate those things. I also want to point out to you that in this chapter, on page, I'm not on page, figure 3.1 and figure 3.2 and figure 3.3, right? We have some pictures of data. Figure 3.3 shows a distribution of numbers that's pretty evenly distributed, like a normal shaped curve. The median is exactly in the middle, right? The median is exact, half the scores fall above it and half the scores fall below it. And by the way, when it's normal like that in 3.3, the mean and the median and the mode are all the same number. They're all at that peak of the curve. That's an important point. Well, you'll see in table and figures 3.1 and 3.2, the graphs, the pictures of the curve are skewed, right? They're skewed. You have the negative skew in 3.2, which shows you that the mean and the median are different. And when it's negatively skewed, the mean is less than the median. And in figure 3.1, again, the mean and the median are different, and that's a positive skew, right? Where the average is, the mean average is going to be above the median, right? So this word skew means pull, right? And that happens when the numbers have a few extreme scores, a few extreme high scores, or a few extreme low scores, right? And the numbers get pulled. In figure 3.1, there are a few extreme high scores pulling that mean way to the right. What is a more accurate representation for the reader of the measure of central tendency for a skewed group of numbers would be the median, as we said earlier, because it ignores the outliers. The median doesn't take into account that there are a few really high scores or a few really low scores. It looks at the center of the list of numbers. And so you might want to play with that a little bit. Make a list of 10 numbers, take the average. By the way, make a list of 10 numbers and don't include an extreme score of 0, right, or 1,000. And take these and make believe they're exam scores. Take the average and see what you get when you calculate the mean. And then do the same thing and put the scores in rank order with those really extreme scores at the bottom or at the top. And then calculate the median and see how those two data sets compare to each other. That's a really nice way to drive this point home, I think. Okay, so that mean, median, mode, measures of central tendency, pretty straight ahead. And keep up with the material. You're going to be moving next into measures of dispersion. In this chapter, we talked about measures of how things cluster together, the mean, the median, and mode. Next chapter, you're going to be reading about a statistic that'll tell you how spread out a list of numbers are. So on a list of exam scores, I want to know the average for my class. Presuming there are no really outlying scores, it would be best to take the mean average, and I can see how clustered the scores were together. I can see what the measure of central tendency is. The clustered piece comes with the next chapter, the measures of dispersion, which will tell me, hey, were those scores, if the average for the class was 85, did everybody get between 82 and 88? Or were the scores really spread out, where some people got a 78 and some people got a 98, and we ended up with the same mean average? Let me explain that a little bit better. So you have a list of exam scores, right, for one class where the scores are all between 82 and 88 and the average for the class is 85, and you have another class where the average is also 85, but some students got 78 and some students got 100, etc., etc. As I always say, if you have any questions about this, please feel free to give me a call, and hopefully we can clear up any confusion. Thank you.